Alright, so in this video I want to have a look at compression and a certain type of compression called run length encoding, or you're more likely to see it called RLE. Okay, so first of all we need to ask ourselves the question, why is it that we compress things? Alright, now the answer is quite simple. The reason we compress things is because some files are just too big to send or too big to store. Okay, so they might not actually be too big to store or too big to send, but they will take a long time to send or a long time to download, or they will take up a lot of memory that you don't want to use on one thing. Okay, so if we compress them, we can make them smaller, and if we can make them smaller, that means they can send faster, download faster, and we can also save space when we are saving them on our devices. All right, so there are two types of compression. All right, number one, we have lossy, and number two, we have lossless. All right, now in the table below here, I've got some ways in which they are different. All right, so first of all, lossy compression, where you might be able to guess because of the name, that means you will always lose quality when you use it. Okay, you will lose quality and you can't get it back, whereas lossless, you won't lose any. Okay, so your file size and your file quality, well, your file size will be smaller when you are sending it and saving it, but when you're using it, the quality will be the same. Okay, so some differences between the two. Right. In lossy compression, when you remove data, you reduce the file size. Okay, so you're losing data to reduce the file size. Okay, in lossless compression, you don't lose any data at all. All right, in lossy, you achieve more compression. All right, that means you can get a smaller file size with lossy than you can with lossless. All right, lossless, your file size will be bigger. Okay, in lossy, all right, you will be your quality of the thing that you are compressing will become less. All right, so if it's a picture, the picture quality will be more poor. If it's a sound file, the sound quality will be more poor, and if it's a video, the video quality will be poor. All right, in lossless, your quality stays the same. All right, now this is a big one, this last one. When you're using lossy, it's irreversible. That data is lost forever. Okay, but when you're using lossless, you can retrieve all your data back. All right, so a few differences of the two different types of compression. All right, the main thing to remember is that if you use lossless, you can retrieve all your data back. If you use lossy, you can't. All right, this bottom one here. All right, lossless has a bigger file size than lossy, but lossless is obviously a better quality because you're getting all your data back. Okay, now just to have a think about compression for a second, if we think about music, all right, if we were to get a 3 minute song, right, which is about average for a music song, and it was uncompressed, and we tried to put it onto your iPhone, for example, it would be around about 35 megabytes. All right, that's pretty big, because once we compress it, it becomes around about 3 to 5 megabytes. All right, 3 to 5 megabytes. Now that is an MP3 player, or an MP3 song, I should say, not a player, an MP3 song. Okay, so an MP3 is a really good example of a lossy file format, or a lossy file that has been compressed. We can change it from 35 megabytes to 3 to 5 megabytes. All right, an example of a lossy compressed file in an image would be a JPEG. Okay, very commonly used on the internet. Another one, a PNG. Okay, use different methods of doing it. but they're both lossy. Alright, and if you, like we did in class, if you save the same picture with a JPEG and a PNG, you will see the PNG is slightly bigger than the JPEG, which is why the JPEG is more common. Alright, both very effective though, both reasonably unnoticeable when you do it, but if you put it next to the original you can tell the difference, because you will lose data and you cannot get it back. Okay, so let's have a look at a type of lossless compression now, and that is called run length encoding. Alright, so RLE for short. Alright, you're going to probably more commonly see it called RLE. Okay, so if we look at this picture here, this is but imagine it's a bitmap image. Okay, it's made up of pixels. Every square in the image represents a pixel. Alright, now we could represent this as saying, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 just in the first row, 11, 12, 13, 14 yellow pixels before we get to a blue one. So we could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 yellow pixels stored, and then have the one blue, and then go back into the yellows. Alright, like so. Now that would just be the picture in its original format. Okay, but if we were to use RLE, we could just say 14 yellow, 1 blue. Alright, so look at the difference in the size. Okay, so you've got 14 yellow, 1 blue. Right, so you've got 1, 2, 3, 4, 5 characters. Right, compared to this one here above, you can see how much bigger it is, and this only really took us up to this point here. Alright, I've gone slightly past there here, so I've gone for the extra 3 at the end, but still you can see the file size, the difference in it, if we can use this run length encoding to encode this image, how much smaller it's going to be. Alright, because we get to miss out all of the repetition, all of the pattern of the yellows, and we just get to represent it with the number that it is and the color that it is. Alright, and every time the pattern changes, we can change it and go back to, and then go back into it. Alright, so we can save a lot of time from doing that, and then when you want to open the file, or once you've downloaded the file and you open it back up, the computer can see from the algorithm that there's supposed to be so many yellows followed by so many blues, and it can create that picture the exact way it was supposed to be. Alright, so that is how run length encoding works. Alright, and it was really briefly an explanation of why we need compression and the difference between the two types of compression. That's it.